Math 3, Unit 8, final review. Today we're talking about trigonometry. We have our trig functions, Sohcahtoa, okay? Remember, you're not going to be able to use a calculator on the final, so some of these things that we're finding, we just leave them in fraction form, okay? If you look here, we have our 65-degree angle. From the 65-degree angle, how would I label this side? Is it adjacent, opposite, or hypotenuse? 8 is opposite, and the x side is hypotenuse. And based on that information, which trig function will I use? Sine is correct. So we write this as sine of 65 equals opposite, which is 8, over hypotenuse, which is x. We have to get x by itself. What do I do? We have x times sine of 65 equals 8. And then what would I do next in order to get x by itself? Divide by sine of 65. And so my final answer is x equals 8 over sine of 65. Okay. If you look at the next one, I'm going to give you a minute or less to solve that, or at least set this one up correctly. Okay, is 11, what would we label that side as? And 17 would be, which means which trig function? Okay, so we have cosine x equals 11 over 17. Now, when you are trying to find the degree, that's when you use your inverse function. And so how you would write this out and how it would look like on the test would be cosine to the negative 1 of 11 over 17 equals x. That's your answer. Any questions? All right, coterminal angles. Remember that coterminal angles, if we're looking at the circle, they end at the same exact point. It just goes around the circle one more time. Okay? So to find a coterminal angle in degrees, you would add or subtract what? 360. Very good. 360 degrees, because that makes one whole rotation, which would get you back at the same point. If you're dealing with radians, you would add 2 pi. Very good. And so this next part says find 2 coterminal angles, one positive and one negative. So in order to find the positive, you would add 360. So 290 plus 360 gives me, very good, 650 degrees. To get the negative, we would subtract 360. But I'm going to flip this around and write it as negative 360 and 290 so that I have the bigger number on top when I'm subtracting. Okay? So I have, this is 0, and then we borrow, and I get 70, but it's negative because we're taking the sign of the bigger number. These are my 2 coterminal angles. Okay? So all I did was 290 minus 360. Okay, when you have radians, okay, when we're adding and subtracting, you want to have a common denominator. We know we have to add 2 pi. So what would 2 pi be as a denominator of 7? Yeah, good. 14 pi is correct, because 14 pi over 7 would reduce to be 2 pi, correct? Okay, and so we have 14 pi over 7 plus 4 pi over 7, and that makes 18 pi over 7. And then in order to get the negative, 4 pi over 7 minus 14 pi over 7. And so you would subtract and get?
Negative 10 pi over 7.
And those are your positive and negative coterminal angles. Do we have questions? Yes?
Yeah, where did you get the 14?
2 pi over 7.
Okay, so you have to add or subtract 2 pi. And so 2 pi originally it has a denominator of 1, but I want to change it so that it has a denominator of 7. And so 1 times what is 7? Well, 1 times 7 is 7. So then 2 pi times 7 gives me 14 pi over 7. So all I did was just get a common denominator. Okay? Yes. Any other questions? Okay, I'm going to turn the page. Are we good? Great.
Yes.
Next, we are talking about reference angles. So there's a couple things to remember about reference angles. One thing is that it is always less than 90 degrees, or specifically between 0 and 90 degrees, okay? Or between 0 and pi over 2 radians. Okay, the other thing is that it always is drawn to your x-axis. It always goes up to the x-axis when you're finding that reference angle. So they want us to sketch it in standard position and determine the reference angle. What quadrant will 320 degrees end up in?
4.
Very good. Quadrant 4 is correct. So we draw it by making our angle go all the way around. Ends in quadrant 4. We draw that out and write that as 320 degrees. If we're finding our reference angle, it always goes up to the x-axis, and this piece from here to the x-axis, that's my reference angle. How do I find out that amount? 360 minus 320, which is 40 degrees. So that is my reference angle, 40 degrees. Okay, now for the radians, we need to set up our circle in terms of 11 as a denominator. So this, remember at this point it's 0, but it's also 2 pi. What would make 2 pi with the denominator of 11? 22 pi. Is everybody okay with that? Okay, and on the other side it should be 1 pi. How would I make 1 pi with?
11 pi over 11.
Good. 11 pi over 11. In order to get the 90 degree mark, we divide 11 by 2, which is 5.5 pi over 11. And then in order to get that at the 270 mark, we would add and get 16 pi over 11. Okay? So which quadrant will 8 pi over 11 end up in?
2.
Quadrant 2. So we draw this. We have 8 pi over 11. And again, my reference angle always goes to the x-axis. And we're trying to figure out this angle right here. How would I find it in terms of radians? 11 pi over 11 minus 8 pi over 11, which equals 3 pi over 11. Do we have any questions? Okay. We already talked about this when we worked on the unit circle, but converting between radians and degrees, we either multiply by 180 over pi or by pi over 180. In this case, if I want to turn 20 degrees into radians, what will I multiply by? Very good. Pi over 180, and we reduce. And we know that we can cancel out the zeros. And then 2 goes into 18 how many times? 9. And we end up with pi over 9. If we want to change it from radians into degrees, we will multiply by what? Very good. 180 over pi. And the whole object is that these pi's end up eliminating, which they do. And then 9 can go into 180 how many times?
20.
20 is correct. And so now I just have left 20 times 7, which is 140 degrees. Any questions? Okay. Next, we're going to use our unit circle, which we already created. And actually, tell her she can keep it. We don't need it. Thanks. Okay, so using our unit circle. Actually, you probably don't even need to use your unit circle, but we're going to see if these statements are true or false. So this first one, we are talking about quadrant 1. Okay? And so if we're looking at our unit circle, this is quadrant 1, correct? We know sine is dealing with what? X or Y? Y. So it's saying, is Y greater than 0? Okay? The values that are greater than 0 are what values? Positives. Okay? Now, in this quadrant, right here, are Y's greater than 0? Yes. So that means that this is true. Because here, sine is positive. Okay? And this also, sine is positive, and then in the other quadrant, sine is negative. Because we're talking about the Y values. Okay, next one, we are talking about quadrant 2. And we're specifically talking about cosine. Okay, so there's lots of ways about looking at it, or a lot of ways of looking at this. Cosine is dealing with your x, and x being greater than 0, which means that x needs to be positive. Okay, so in quadrant 2, is cosine positive or negative? Negative. Very good. Cosine is negative here. Where else is cosine negative? Quadrant 3. And where is cosine positive? Very good. And so in this case, if we are looking at quadrant 2, is this a true or false statement? False is correct. Okay. So I'm going to give you about 30 seconds here, maybe a little more, to figure out tangent. Do you remember what tangent represents in terms of letters? Y over x is less than 0. And less than 0 means it would be negative. So I'm going to give you a minute to think through that. If you show me a 1, that means true. If you show me a 2, it means false. No.
What the? Negative isn't less than 0.
Yes.
Negative isn't less than 0.
Oh, no. Oh, I read it.
This is true, this is false.
Oh.
Good. Okay. So the correct answer is false. Okay? So we're looking at this quadrant. Remember that it's y over x. In this quadrant, if we're looking at y over x, the y value is what? Negative. Divided by the x value is negative. And a negative divided by a negative actually makes a positive. And so this would then be false. A positive, because this is positive, a positive is not less than 0. So this is false. Okay, I'm going to give you another minute to try to figure out this one.
Can you fill out the rest of
So yes, on this one, here it's a positive and a positive, right? So tangent is positive. Here, your y is negative, or sorry, your x is negative, your y is positive. So positive and a negative make a negative. So in quadrant 2, tangent is negative. In quadrant 3, we just found out that tangent is positive. And in quadrant 4, x is positive and y is negative, which means that tangent would be negative. Okay.
Were you able to write that little cosine
Yes.
onto the
Yes. Yes. Okay. So now we are looking at quadrant 4. And you can show me your answers on your fingers. Again, 1 is true, 2 is false. Good. No, no, yes. Good, 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 good. 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 1 is true, 2 is false. There you go. Good. Okay, so quadrant 4, which means that we are looking right down here. Again, we're dealing with tangent, which is y over x, okay? And this quadrant, y is what? Negative divided by x is positive. And a negative divided by a positive makes a negative. So tangent is negative here. This is saying, is tangent less than 0? Is tangent negative?
Yeah.
Yes, so it's true. So you should have shown me a 1. 1 is true, 2 is false. Okay. Are we good? Okay. Any questions? All right, let's turn the page. Again, you're going to use your unit circle on this. Okay? You should have this right now near you. And so if you find 210 degrees on here, do you see 210 degrees?
Yeah.
Okay? This is the ordered pair that matches up. So I'm just going to write the ordered pair here, which is negative root 3 over 2 and negative 1/2. Cosine, though, is specifically dealing with the x. And so this right here is my answer. Negative root 3 over 2. Okay? 315 degrees. What is my ordered pair at 315 degrees? Very good. Root 2 over 2 and negative root 2 over 2. And sine is dealing with the y. That is my answer.
Wait, so how do you know when it's at 315?
Here's 315 degrees. Here's our ordered pair that we already did all the work for this. Are we okay?
Yeah.
All right, 390 degrees. That is not on my circle right now.
Just go to 30.
Go to 30. How, if I didn't remember this, if you have something greater than 360 degrees, what can you do to figure out where you should be? Yeah, just subtract 360 degrees and we end up getting tangent of 30 degrees. And if we go to 30 degrees on here, my ordered pair is root 3 over 2 and 1/2. Now, tangent is what? Y over x. And remember, because these each have the same denominators, when I write them, they would end up, the denominators would cancel out. And so it is 1 over root 3, but is that an acceptable answer?
No, so it's root 3 over 3.
It ends up being, when you multiply by root 3 to both the top and the bottom, we get root 3 over 3 for this answer. Cosine of 180 degrees. What is my ordered pair at 180 degrees?
Negative
1,
1, 0.
0, but we know that cosine represents the x. Okay, now we're going to work with radians. Are we ready? So, sine of 3 pi over 4. What is the ordered pair at 3 pi over 4? Negative root 2 over 2 and root 2 over 2. And sine is dealing with y.
Y.
Good, thank you. Okay, tangent of 11 pi over 6. 11 pi over 6, what's my ordered pair?
1/2 negative.
Root 3 over 2 and negative 1/2. Okay, but tangent, we know, is y over x. And so that means we would have what? Negative 1 over root 3. And then when we simplify that, it will be negative root 3 over 3. Are we good there? 4 pi over 3. What is the ordered pair?
Negative 1/2 negative root 3 over 2.
Negative 1/2, negative root 3 over 2. Cosine is the x. Negative 1/2 is my answer. Last one, tangent of 3 pi over 2. What is the ordered pair at 3 pi over 2? 0, negative 1.
We know that tangent is y over x, and so if I write that, how would I write it? And anytime you have 0 in the denominator, it is undefined. No solution. 0 on top, if it would have been 0 over -1, then it would have been 0. Do we have any questions? Okay. Next, solve for the degrees. So we're trying to find out what values would cosine, what degree would the cosine be of -√3/2? So, first of all, it's saying cosine is negative. What quadrants is cosine negative in? We know that cosine is x, right? And we want it to be negative. And if you said quadrant 2 and quadrant 3, you are correct. So all we're doing is looking for an x value in quadrant 2 and in quadrant 3 that is -√3/2. And if we look at our unit circle, x is -√3/2. Do you see it?
Yeah.
The degree value is 150 degrees. Okay, x right here, -√3/2. The degree is 210, and you're done. That's your answer. Okay, moving to the right. Tangent is not by itself. What do I do to get tangent by itself? Very good. Tangent of theta equals -1. Now, where is tangent negative? Okay, so tangent we know is y over x, and tangent is negative in, good, 2 and 4. So we're looking at y over x. In order for them to reduce to be -1, both the y and the x value would have to be the same. Very good. So 135. If you have √2 divided by -√2, that's going to reduce to be -1. So 135 degrees. And then in quadrant 4, what is it? Very good. 315 degrees. Okay, this next, they want us to do the exact same thing except for give the answer in radians instead of degrees. Change this problem on your notes. So it should be 2 sine of theta equals √3. And what will I do in order to get sine by itself? Very good. So we have sine theta equals √3/2. We know that sine is dealing with y, and we want y to be positive. And what quadrants is y positive?
1 and 2.
Quadrant 1 and quadrant 2. So we go to quadrant 1 and 2. We want to find where is y √3/2. 60
120.
and 120. Oh, but we don't want to write in degrees, right? What are we writing it in? So it's going to be
2 pi over 3. Or pi. 2 pi over 3.
okay. So pi over 3. Okay, and we have to put in radians because of that. All right, any other questions there? Okay, next one. We just set each of the factors equal to 0. It's already been factored for you. Okay, so here this is saying cosine of theta equals 0. That's saying x equals 0. Where does x equal 0? Pi over 2, because we're dealing with radians. And where else? Very good. Okay, now we solve this other side. We have 2 sine of theta minus 1 equals 0. What would I do to solve this?
Add 1.
Good. Add 1. Very good. 2 sine of theta equals 1. We divide by 2. And so sine of theta equals 1/2.
sine is dealing with y, and where is y positive? Quadrant 1 and quadrant 2, and pi over 6 and 5 pi over 6 are correct. And so all 4 of these are your answers. Any questions? Okay. We good? Okay, last page here. So your sine and cosine graphs have been drawn for you. Okay? Remember that we normally mark these all with X's, and then we end up making our points once we move them. If you were to look at your unit circle, okay, remember this is dealing with the y values, okay? And so, starting at 0, this y value is at 0. And then you see at 90, the y value is 1. And so that's where it goes up here to 1. And then when you go to 180, which is pi, the y value is back at 0. And then the y value goes to -1. And then it goes back up to 0 when it gets to 2 pi. And this one's dealing, cosine is dealing with the x's. And so same thing. So see how the x starts at 1. It starts up at 1. And then it goes to 0. And then it goes to -1, and then back to 0, and then back to 1. And so all of the information for these graphs are on your unit circle. Okay? This is dealing with a sine graph. Okay? A couple things that we need to notice are negative means that it's going to reflect. What does this 2 mean? It means an amplitude of 2. So instead of it going up to 1, like a regular sine function, it has an amplitude of 2, so it's going to go up to 2 and down to 2 instead of up to 1 and down to 1. And then this +1 right here, what does that mean? It's going to translate up 1. So we're going to do our starting points here. And again, we're looking at our sine function. Okay, and so we know sine starts at 0. 0 times 2 is still 0, correct? Now, when we would normally go to the 1 right here, because of this being reflect, it's going to go to -1, and it's an amplitude of 2, which means it'll be at -2, because it's multiplying. So it's going 1 times 2, which would be -2. And then we're still back at 0. And then instead of this one being at 1 or +1, it's going to be at +2 and then back at 0. So looking at this graph, do you see this one here at the top? That's like your normal one, except for because this one was at +1, because of the negative, it went down to -1, and because of the 2, it's -2. And this one would have normally been negative, but it went up to the positive side. Okay, now there's still one thing. So we've taken care of reflection, we've taken care of amplitude of 2, and now we need to move it up 1. So all I do is go to each of my x's, and I move it up 1, and I'm going to make my point, because that's actually where my graph is going to be. The x's were just helping me. So each x, I'm just going up. Oops, I did not go up 1, I went up. Yeah, I did go up 1. Okay, sorry, up 1. Up 1 on every x. And then you just draw your curve. Sorry. So let's stick with the sine function, and we'll do the next one down. Is that okay? Okay, so what does the 3 mean? Okay. Amplitude of 3, that means we're going to go up to 3 on everything. And there's no reflection this time. Okay, so my first x is at 0. And then in here, it's going to go up to 3. And then again, we're at 0. And then we go down 3, and then we're at 0. Okay, and so I just took care of all those amplitudes of 3. Okay, so then the next thing, and we're going to actually do two things at once here. This plus pi over 2 means what? Very good. Left pi over 2. And this negative 2 means you're going to go, very good, down 2. So we're going to do two things at once. Each x, I'm going to go left pi over 2, which is one marking, because a whole marking is pi. Do we see that? Okay. Or 2 markings is pi. So we're going to go left pi over 2 and then down 2 and make our point. And I go to each of my x's and do that. So I did that for this x. Now I'm going to go here. Left pi over 2, down 1, 2. Okay, going to my third x. Left pi over 2, down 1, 2. Okay, my fourth x. Left pi over 2, down 1, 2. And then the last one, left pi over 2, down 1, 2. And it should make the same curve as my other sine functions. If it doesn't, then we probably did something wrong. Okay. Any questions? All right, so now let's look at the cosine graph. So the markings are all the same, but we need to pay attention. This right here means it has amplitude of 3. So let's make our markings. It normally starts at 1, but instead of starting at 1, it's going to start at 3, right? So I'm going to make an x here at 3. And then 0 times 3 is going to be 0 still. At pi, it would normally be at 1, but it's going to go down to, very good. And then here, at this marking, it's going to stay at 0. And at 2 pi, it's going to go up, back up to 3. And then what does this mean? Right pi over 2. So each x, we're going to go right one marking, right pi over 2. So starting with my first, I go right 1, or right pi over 2, make my point. Next x, right pi over 2, make my point. Right pi over 2, make my point. Right pi over 2, make my point, and the last one. Okay, so all we're doing is translating it, and then it makes our cosine curve, which looks kind of like a U. Questions? Okay, last cosine one. What? Very good. So first of all, this right here means reflect, and the 2 means amplitude of 2. Okay, so we normally would start at 1, but because of the reflection, we're going to be at -1, and then because of the amplitude, we'll be at -2. Is everybody good with that? Okay, and I'm going to make an X there. 0 is the next one, which doesn't change. At pi, it's going to be where? 2, and then we go back to 0, and then at 2 pi, it's going to be at -2. And then we do our translation. This plus pi right here means I'm going to go left pi, and the plus 3 means I'm going to go up 3. So we start at the left side, and we're going to go pi, which means it's really like 2 markings over. Do you guys agree? So left pi, and then up 1, 2, 3. That's my first point. Then I go to my second x. When we're going left pi, it's 2 markings, 1, 2, and then up 1, 2, 3.
My third marking, I go left pi, which is 2 markings, up 1, 2, 3. Fourth marking, left pi, up 1, 2, 3. And fifth marking, left pi, up 1, 2, 3. And then make our curve. Any questions?